So hopefully you've now done part A. If not, click somewhere up there and let's get on with part B. So first bit of advice for part B, if you can't do part A, still try part B. They give you a show that, they give you the information to part A, use it, try and at least scoop a few marks from part B, even if part A was a no-go. In part A, we were talking about the coordinates of P and Q, but we never actually found what they were. So definitely the first thing here is find what P and Q are in terms of their coordinates. Let's do that. So if tan of 2x is equal to root 2, then what we can do is we can do the inverse tan of root 2. Don't know if that's visible, but that gives us a weird answer of 0.95531666181. Finding the other solutions of tan are really nice. If I give a very quick sketch of a tan diagram, solutions are always 180 degrees or pi apart. So take this answer and add pi to it, and we get 4.096909272, obviously. There's only 2 points. There's only P, there's only Q. So there's no need to find any extra solutions. Now let's divide by 2. If I divide by 2, we're going to get these two lovely values. These are only the x coordinates. What would we want the y coordinates? Well, let's plug it back in to f of x and see what we get. So plug it back into the very original function up here. I'm sure it's going to be a jumble of decimals again, but let's find out. Actually, I've just read it again, the actual question. Let's read the question properly, probably a good idea. It says find the x coordinate only, so let's not bother finding f of x, there's no need. Now we've got our values of x, so we know that p is going to be this one and q is going to be this one, simply because p is first on the diagram and then q is next. We now need to think about what does y equals f of 2x actually mean. So when there's a 2 in the middle, it means that we are shrinking it, still call it an enlargement, but we are actually shrinking it by a scale factor of 2. So we're almost halving it. So if we know that the p coordinate here is 0.47, etc., etc., and that's here, if we're going to shrink it by a scale factor of 2, then surely the x coordinate of p will be that number divided by 2, which is equal to 0.239 once I round it to 3 significant figures. It doesn't ask me to round it to anything in particular, so do 2 or 3 significant figures and you should be fine. And the x coordinate of q will be this value divided by 2 in the same manner, because everything is getting squished by a scale factor of 2, which is equal to 1.02 when we round to 3 significant figures. Reading the question again, I have obviously assumed what the question is asking and not read it properly. The question is looking for the minimum point. Where's the minimum point going to be? It's going to be Q. So that's going to be the answer, and turns out we don't need what P is. Anyway, we found it. Now we're thinking about part 2. We're doing y is equal to 3 minus 2f of x. Minus f of x means we flip it. We reflect it in the x-axis. That's because anything that's positive in terms of y, we're going to make negative. So points above the x-axis are going to go below, points below the x-axis are going to go above. The 2 here means that we are stretching it in the y direction. That's not going to affect the x-coordinate, so who cares? And the 3 here, that's going to represent moving the whole graph up by 3. Again, that's not going to affect the x-coordinate, so who cares? The only thing that we care about really is this minus. If I draw it, I'll draw the succession and you can see that the x-coordinate won't change. So first of all, I'll do 2f of x. So 2f of x will stretch everything by 2 in the y-axis. Minus 2f of x will flip it, as I say. And then 3 minus 2f of x will move everything up by 3. Somewhat like that. But the x-coordinate, and the x-coordinate have not changed. The only thing you have to be careful of is, can you notice that the maximum has now changed to a minimum? So now that I've read the question, it's talking about minimums. We only care about the new coordinate of p, which is down here. So what's actually happened? Well, nothing. The coordinate of p has stayed the coordinate of p. So at the minimum, x is simply equal to this number here, 0.478 if we round it. So I should probably follow my own advice there. Definitely read the question more carefully. We only care about minimums, so we don't need this value up here. But this would be the minimum, which is q, when we shrink it by 2, and this would be the x-coordinate of p, which becomes the minimum once you do the flip. Well, there you have it, our 8-mark differentiation and functions question all done. Try these extra questions if you want. Catch you in the next one.